Hello and welcome to ThePrint. My name is Soumya Pillai. I'm a senior assistant editor covering environment and science here. And in this video, we'll be continuing our series of interviews with the first Vigyan Puraskar awardees. A little bit of context about the awards itself. Last year, the Ministry of Science and Technology had centralized the science awards in the country under the umbrella of the Vigyan Puraskar. There are three categories in the new set of awards. The Vigyan Ratna, which is the highest recognition for science and technology. We have Vigyan Shri, and then we have Vigyan Yuva Shanti Swarup Bhatnagar Awards, which is to recognize the work of young scientists in their respective fields. And today we have a very special guest who is the awardee of the Vigyan Yuva Puraskar, Dr. Roxy Koll, in the category of Earth Sciences. He is a climate scientist with the Indian Institute of Tropical Meteorology in Pune, and he has done extensive work in the field of marine heat wave, extreme temperatures, climate change. He was also the lead author of the IPCC reports in 2019 and 2021. And anybody who follows climate and environment news closely must have seen Dr. Koll in TV interviews. He's extensively quoted in news reports just because of his rich body of work in the subject. Welcome to ThePrint, Dr. Koll, and congratulations on receiving the Vigyan Yuva Shanti Swarup Bhatnagar Award this year. Thank you for joining us.
Thanks a lot, Soumya. It's a pleasure to be here. And thanks to ThePrint for highlighting science and scientists, okay, who are the building force of the country. And it's quite important at this stage, especially when we need climate research, development, and related support to guarantee or safeguard the lives and livelihoods of the huge population of the country. Thanks again.
Thank you, sir. I'm not going to waste any more of your time, and I'm pretty sure the viewers are also quite keen on listening to you about the subject. Sir, just to get the interview started and just for the benefit of our viewers, if you could just tell us a little bit about your work in the field of climate science, climate change, and especially on the on the subjects of climate change and extreme climate recordings.
Right. So if you look at India or the larger Indian subcontinent, this is one region which is bombarded with a lot of extreme weather events that even the IPCC, that the Intergovernmental Panel on Climate Change and its reports have mentioned that will happen. That is happening at the fastest rate or is going to happen in the future. So all these things, extreme weather events in terms of the floods, droughts, heat waves, cyclones, sea level rise, storm surges. Yeah, all this is happening over this densely populated area. India, we used to see India as a region in between the seas, surrounding seas, and the Himalayas. But now we see the seas are warming quite rapidly, churning out these extreme weather events, and the Himalayan glaciers are melting also rapidly. Resulting in all these kind of extreme weather events. So as a scientist, as a climate scientist, my job is to understand how the global change is impacting us locally, not only to understand, but also to see how we can model or predict these changes and variability, and also project them for the future in the next 10, 20 years, how it is going to change, so that we can frame policies on how to tackle these bigger challenges. So that's a nutshell on how what I work on. I worked on when we talk about extreme weather events. Most of it is linked with the monsoon. In this monsoon season itself, we saw a lot of extreme weather events. For example, the Wayanad landslides in response to extreme rains that happened in Kerala and also elsewhere in the country, like in Himachal Pradesh, UP, and other regions also. And the preceding heat waves also, the heat waves which killed many people in the country. So we are looking for understanding these kind of events, quantifying these events so that we can predict them better and also frame the policies better for future. Yeah.
So you did mention about, over the past few years, we have been seeing, natural disasters which are pushed by extreme climate events. Wayanad, which is also your home state, Uttarakhand, Himachal. Before this, we had like a very bad spell of heat wave. I mean, in the coming years, are such events going to get worse? And what is the importance of early warning systems and weather forecasting under this scenario? Also, the kind of work that is happening in IITM Pune under your aegis to forecast these events better. If you could just tell us a little bit about that.
We don't call them natural disasters anymore. Yeah, these are man-made in several respects. And if you look at global change, one of the indicators is the global surface warming, mean surface warming, and that is about 1.2 degrees Celsius, and we have crossed that. And we are soon reaching 1.5 by 2030, and by 2050 we are reaching 2 degrees Celsius. And even with 1 degree Celsius, we see a huge impact in terms of rising extreme weather events. And we call it a disaster when these hazards or risks manifest and we are unable to save lives. And that is within the scope of human beings on locally as well. Yeah. So because we have identified us in terms of many of these extreme weather events that we are talking about, we have identified many of these hotspots. It is potentially possible that we save lives over these regions. Yeah. So if a disaster happens and people lose their lives or livelihoods, it's our collective responsibility as well, right? So we don't call them natural disasters anymore. They are disasters, and in large due to man-made interventions at multiple levels, from global to national to local. So we have a collective responsibility on that. And at IITM, what we do is, again, there are different departments here working on from monitoring these kind of changes at multiple timescales, like at weather timescales, like few hours to few days to few weeks. And we also try to forecast these events at these timescales so that we can take immediate actions based on this forecast. Then there are seasonal forecasts, like for example, 2 to 3 months before the monsoon, we prepare the forecast so that as a country as a whole, we can be prepared of how the quantum of rainfall for that year, like in April, we might give a forecast saying as a country as a whole, okay, we might receive normal monsoon or below normal monsoon, but this is a country aggregate. Okay, it doesn't give much specific details. And also there is climate projections based on climate models that we have developed in-house. I was also part of it in the initial stage. So these are Earth system models based on the same framework which we use for the weather forecast, where we put the ocean, the atmosphere, the land, the physics of it, the chemistry and the biology of it all together in huge high-performance computers, and try to see how the climate will turn out in the next 10, 20, up to 2100, yeah, so that we can plan accordingly. For example, the government has come up with the Amrit Kal perspective by 2047, that is by 100 years, we should be able to do so and so things for the country, so that it's for the benefit of the people. And even the United Nations World Meteorology Organization has come out with a plan called Early Warning Systems for All, which means that each and every person in the country should benefit from early warnings so that they can safeguard their lives. Nobody should be left out. Yeah. And it is in this direction that the institute is also working, so that we do the research and development that contribute to these forecasts and climate projections, which are then, periodically transferred to the Met Department. Now, they are the operational wing, the Met Department, which is also under the Ministry of Earth Sciences, just like Indian Institute of Tropical Meteorology, our sister institution. So they periodically receive our inputs and our models, and they run on the same high-performance computing, which is situated at IITM, which is the fastest supercomputing facility. Yeah. So these are, I would say, now considering the climate emergency, considering the extreme weather events, this is a kind of a backbone of the country that should help in our daily lives and our future as well. That's the work of IITM.
So just a follow-up question, because we were talking about Wayanad also. How effective would these early warnings be in a situation of a disaster, especially considering that there is also a high level of unpredictability that such events carry. So in the case of Wayanad, if we had a robust early warning system, and there was a lot of criticism that IMD could not foresee such a large event, do you think if there was a robust early warning system, we could have minimized at least, some kind of damage in this particular event?
Exactly. Thanks for reminding this. Coming back on this question, I would love to answer this question. This is very critical that we dissect this particular event as a case study, because more than 500 lives were lost, which could have been saved. Yeah. Now, there are three factors here in terms of understanding this event, which concerns to monitoring and all, and forecasting this event, which is a reactive action. Based on forecast, you evacuate or do something in a few hours' time, or policy side. Yeah, I would like to talk about these three aspects. So one is the monitoring side. Okay, and I had a look at rainfall measurements over Kerala. Put forth, I have the maps from both India Met Department and the Kerala State Disaster Management Authority, KSDMA. Both maps were starkly different, which means that we do not even have accurate measurements of rainfall that happened at many of these locations. So this is one major gap. Without understanding that, we may not even understand how these landslides manifested. We will be, looking for the pin in the haystack or in the wild, without data. So data is a critical part in understanding these events. We can talk about more of that later. And the second thing is forecast. Now, the forecast that the Met Department, I should compliment the Met Department, saying that they have the state-of-the-art forecasting system. If you consider global forecasts, our forecasts are state-of-the-art. We use the same global forecasting techniques that anywhere in the US or Europe use. But there is one challenge here. We have tropical weather, especially Kerala, where the interaction is with the Arabian Sea, and we have the Western Ghats, where these interactions manifest quite fast. So these fast-moving, short weather systems, this is a typical example of weather that we see in India and over Kerala as well. So these weather systems develop so fast, maybe in half an hour, in 1 hour or 2 hours, and the uncertainty, or it carries a lot of unpredictability, just like you said. So the predictability factor is much less in these regions compared to other regions in high latitudes or in Europe or US, where the weather systems are large systems, slow moving, developing in a few days' time. So there is more predictability there. That is one thing about the forecast. The second thing about the forecast is what the Met Department provides is rainfall forecast only. There is a system only to provide rainfall forecast. I'm talking about the landslide thing. So if a yellow alert or an orange alert is given, that is based on the rainfall forecast only. It doesn't provide or include the information that okay, landslide will happen, flash flood will happen, or some impacts will happen on ground. It doesn't say, because that is not a part of, at least in the immediate purview of the Met department. It's a meteorological department. It's not a geological department. Yeah, this is because our institutions work in silos without transdisciplinary, trans-department approach, which are so these departments are with different ministries, even some of the departments. Yeah, and so what happens is they can. The Met Department can give indications, even in this case, on that day when the landslides occur. There were some bullet points which indicated that landslides might occur and so on, line by line. But these are not forecasts. Okay, the forecast is only on the potential rain amounts which will happen, and this can happen. So, for example, if you are in the coastal area, the impact will be different. In the midlands of Kerala, it will be different. In the plains of some other place in India or Kerala, it will be totally different. Yeah. So 150 millimeter of rainfall, if it falls over the highland with hills, particularly if those are vulnerable hills, it can potentially cause landslides. But if you want to say, or if you want to call it an early warning system, which with potential impacts on ground, we need to connect this rainfall forecast to subsequent landslide forecast. Yeah, based on the slope of the land, based on the soil condition, based on the amount of rainfall that the soil has soaked during the last several days. We have the science for it to do that, but that also needs you need data from the geological department, maybe from the water commission and other departments to connect it with the river also. You see, it's going through multiple departments. Yeah, which means that we need a framework, interagency framework, interministerial framework, or maybe a R&D, research and development department, where you can bring in all these agencies, make an early warning system where you have the capacity to push these departments to share the data, to work together and make an early warning so that it can be passed on to the state and national disaster management agencies. And that's the same thing for Wayanad. We could have done that. Yeah. So that's the forecasting thing. Now, just quickly about the policy also. We always depend on forecasts. Yeah. Even in the media or otherwise also, we keep on saying why forecasts were not given in the right time. Yeah. But if you look at that, forecasts do not always save lives or livelihoods even. Now, again, go back to the Wayanad case or the Uttarakhand case or the Himachal case. Their livelihoods are lost, their property, their houses are gone, washed away. Yeah, and for the people remaining, they cannot go back and start back their lives. Yeah, so which means that we need to have strict policies, and this is again policy possible with our technical know-how, with our current understanding, current finance status. It is quite possible to identify hotspots. We have already identified these hotspots. Many of the disaster management agencies have the hotspots in terms of landslides, in terms of heat waves, extreme rains, and so on. If you identify hotspots and if you know it is hazardous for life, we need to take precautions accordingly. We need to make sure that people do not live there because we need to safeguard their lives. And we need to make sure that there are no huge land development changes in these regions. Yeah. So if we can do this, monitor, forecast, and policies, we can safeguard lives and livelihoods. And whether it's the case of Wayanad in Kerala or Uttarakhand or Himachal, this is the same story. It's not that we do not have the systems to do that. We need the will, and we need to build that framework. That is possible.
So moving on, a few months back, there was a paper that you had published on the unprecedented warming of the Indian Ocean. You've also spoken about the warming of Arabian Sea in comparison to Bay of Bengal. Could you tell us a little bit about the findings of your study, also the kind of risks that this would have to the Indian subcontinent and the coastal states of India?
Yes, this is a quite important study for the entire Indian subcontinent, not only India, but also other regions of South Asia which are facing similar extreme weather conditions. So what it says is that this is a research from IITM, from our lab. What it says is that we know that the globe is warming rapidly in response to carbon emissions. Now, where is the heat going? More than 93% of the heat from global warming is actually going into the oceans. It's absorbed by the oceans, the land, the atmosphere, the ice, all these other elements together absorb only 7% of the heat from global warming. Yeah, 93% are going to the oceans, and out of the oceans, again, it's not uniform. Indian Ocean is absorbing roughly a quarter, depending on the period, it will be different. Sometime back, we estimated it was close to a quarter. But we see that Indian Ocean is already naturally, it's the warmest ocean, and it's also warming at the fastest rate. So if you compare the tropics, the Atlantic or the Pacific, which are large oceans, the Indian Ocean basin, which is landlocked, that is one reason why most of the heat is concentrated in the Indian Ocean, because over the north compared to the Atlantic and the Pacific, it's doesn't have a way to flush out the water to the poles in the north, because it's landlocked by the Asian subcontinent. Yeah, and that's one reason. So because of these things, the Indian Ocean is warming rapidly at a fast pace. And when you have warm waters, these provide consistent supply of heat and moisture for weather events, whether it's cyclones or the monsoon to be erratic. Yeah. So we see that compared to Bay of Bengal used to be already was one of the warmest basins. So it used to have cyclones every year. Arabian Sea, maybe one cyclone in every 2 years. But now we see that roughly every year we are having a cyclone. There is a 52% increase in the number of cyclones in the Arabian Sea. Also, the monsoon which flows through the Arabian Sea is energized by the heat and moisture supply. Yeah. And so there are more fluctuations in the monsoon. So there are episodes when it's bringing all that moisture in a short spell of time. Yeah. And that falls in a few days to few hours time. And this is also a global warming property. When the air is warmer, the warmer the air, the more moisture it holds and for a longer time. So it doesn't rain for a long time. Yeah. And we are seeing this in our monsoon conditions, not only for regions like Kerala, entire central India, northeast India, and parts of north central India, including Uttar Pradesh and other regions as well. Yeah, Gujarat also. So entire central Indian belt, entire regions which are the Western Ghats, the northwestern part, central India, and towards the east and northeast. We see that there are episodes where you see long dry periods and intermittent with short spells of heavy rain. So you get a seasons or a month's rain in a few days to few hours time, like cloudburst, almost like cloudburst. Yeah, and the unpredictability also increases. So as we improve our models, we see that the unpredictability also is increasing due to climate change, which is bringing more errors in this forecast. So we are unable to forecast the exact intensity of this event and the exact location of this event, because we need to go high resolution and we need to go microphysical in terms of coding this physics into these models. So there are a lot of challenges that we need to work on.
Sir, I'm going to come to the awards itself. First of all, your reaction on receiving the award, and also there was a lot of controversy around the centralization of this award last year, because it was almost sort of a lot of the awards and grants that are given to the scientists were sort of cut to size to make this into an umbrella of Vigyan Puraskar. A lot of young scientists were not very happy that the cash incentive that was given with a lot of these grants were taken away. I mean, what are your thoughts on the centralization of the awards itself, and also your reaction to receiving the first Vigyan Puraskar awards?
Exactly. Well, I would say I am totally overwhelmed by this award. I consider this as a reward for the collective research in climate change in India, and also the voice that we have as scientists put forth. Initially, I used to get a lot of challenges. It was difficult for me to bring that science to society, and a lot of challenges, internal, external. You can guess for a scientist to talk to the media, it's quite challenging. But now the scenario has changed because we understand the challenges. In terms of climate, and we see the urgency on bringing that to the society, the science, and the benefits of doing that. So the science is rewarded, the science communication is rewarded, and I feel overwhelmed. And also, I feel a sense of huge responsibility suddenly dawned over me. So in that ways, I'm totally happy. I'm also happy in terms of, when we just call it centralizing and nationalizing, I feel good about it because it's the government is rewarding. The government is rewarding as a country. It's rewarding. It's not just one agency or one institution that is rewarding this award. So I'm totally happy. All the awardees were happy in terms of having their work and their institute's work recognized. So in that part, definitely perfect. Now, in terms of scraping many existing awards and the cash prizes and the incentives that used to come with it, I'm totally unhappy about that, I should say, because I think scientists should be encouraged and supported massively. Scientists generally do not, the institutional support generally in the country, especially in national institutions, are relatively good. Like in my national institution, ministry institutions are well supported by the government. But I feel that many other national institutions and universities, IITs, ISER, Indian Institute of Science and Education and Research, they are not that supported. And we see, especially in universities and all, the quality of research, the financial support, everything going downhill. And it has happened over the last several decades. We need to bring that back. We need to encourage our scientists, our professors, early career researchers, students. And we see that the support that they get in terms of salaries, in terms of the research grants, are not up to the potential where we can work towards the betterment of the country. There's a huge potential in these scientists that can make a transformational change that we need. That's where I am reaching, because incremental change is happening already in the country. But in terms of climate challenges and the other challenges, whether it's in the health sector or climate change sector, we need transformational change to adapt and mitigate these impacts. And for that, scientists have to be encouraged thoroughly. The previous Bhatnagar award, the awardees used to get 25,000 per month until they are 65 years old. This used to be a major incentive where they can thoroughly focus on, they're happy and they don't have to worry about other things, whether it is concerned with their life or career. And they used to get 5 lakh lump sum, and also they used to get 15 lakh in grants for research. All this used to support their research only. You can see anywhere you look, whether in India or outside India, internationally, you don't see scientists, lavishing on luxury because they got some additional research grants. Yeah, this only helps them improve the quality of their research and life, and it is immensely important. I would request that the government to rethink about this. Yeah, and I think scientists should voice about that, and also we need to have local awards from different bodies, so that it is not just a few that is awarded or recognized at the highest level. Yeah, we need awards by scientific bodies and associations. We need awards by professional bodies. We need awards by local governments, state governments, national governments. These are important. This encourage. I have seen scientists motivated because of awards, and they lead a longer useful quality career life, definitely. And that's my opinion about these awards.
Thank you, Dr. Koll, for speaking with us, and congratulations again for this very, very well-deserved honor. I would also like to thank our viewers for joining in for this interview with us today. Thank you so much. Thank you for tuning into The Print. You're with Soumya Pillai. Thank you.
Thanks a lot, Soumya. It was a pleasure to talk with you. And I'm always happy that The Print is highlighting the science and scientific research of the country. Best wishes.
Thank you, sir. Thank you. Thank you for joining us again.